Hi. Okay, hello again. Let me see if I can talk to you about graphing a line here. There is a formula y equals mx plus b, which is a slope-intercept form. M stands for rise over the run. Now, between 2 points, horizontal movement is the run, vertical movement is the rise. B is the y-intercept. It's where the graph intercepts the y-axis. So there's your y-intercept, the b value. Slope is essentially how a line slants. If the slope is positive, essentially you're going to slant upward. If the slope is negative, you're going to slant downwards. So that's what we're looking at. So I have an example here, y equals 3x minus 2. Notice the m is 3 and the b is negative 2. The slope, because it's a ratio, and this is a whole number, we're going to write it as 3 over 1 to put the rise over the run here. Because any whole number, you can do that. Any integer for that matter. Any real number, really. Anyway, the top number tells you the rise. Because rise is y value, positive means up. So this is positive 3, so it means go up 3. The x value is horizontal. Positive means to the right, negative means to the left. So this means essentially right 1. Negative 2 is your y-intercept. That is where the graph begins. That's your starting point. Now, for a lot of you, I'm pretty sure this might be really easy, but just bear with me here. So, I'm going to go down to the point 0, negative 2, or the y value of negative 2 as your intercept. Then I'm going to rise 3 values. So I'm going to go up 1, up 2, and up 3. So 1, 2, 3, I'm here. And then I'm going to scoot over 1 unit to the right. So up 1, up 3, right 1. These 2 dots, I'm going to connect them the best I can. And I'm going to try to stay along the same trajectory here. So the idea here is, from this point, if I go up 1, 2, 3, and I go across 1, I'll be at my next point. So the slope, you don't have to do that, but I'm just going to add another point in there. That's essentially how you're going to find every other point in the graph, or at least enough points so you can graph. Usually 2 points is enough, but sometimes I like to go 3, just so you have that idea. So 2, let's say y equals negative, let's say y equals negative 3/4 x plus 1. Your slope would be negative 3 over 4, and then your y-intercept would be positive 1. Now, because the slope is a ratio here, you can't put negative to the numerator and the denominator. So this negative 3 or negative 3 over 4, you can put the negative to the 3 or the negative to the 4, but not both. So I'm going to choose the negative to go to the top. So because this is negative on top, and this is a vertical, this is up or down, this would be down 3 spots. Because the bottom is positive, this means right. So the top number means up or down, positive up, negative down. The bottom number means right or left. Bottom is positive, you go right. Bottom is negative, you go left. Your y-intercept is positive 1. So this one shouldn't be so bad. Start at positive 1. Move down 3 spots. So down to 0, down to 1, down to 2, negative. Down to negative 2. So down 3 spots. Now across from this way, 4 spots. So down 3, right 4. Again, I'm going to turn this because it's harder for me to draw this way. Let me turn this. I'm sorry it's upside down here, but I'll put it right side up in a minute. the best of your ability, connect the two dots. And in certain instances, I like to continue to go down a little bit further, if I may here. You don't have to do this if you don't want. But notice if I go down 3 more spots, if I happen to do it one more time, because I can do as many times as I want. I go down 3 spots. And so this is easier to graph. I know I kind of put this really off here, but let's just say like this. So that'll be my next point. You don't have to draw all 3, but that's essentially how you graph this lines. So notice the slope is equal to negative 3/4, which is negative. The graph decreases. The graph goes downward. Here the slope is 3, which is positive. The graph increases or goes upward. It's all the same. Then another quick example here. Let's say you take away the x value. So let's say the graph y equals 3. So what you do is you think like if it was y equals 0x plus 3, to where in this particular case the slope is 0, but you need it as a fraction, so you put a 0 over 1. Because the top is 0, there is no rise. This would be run 1 to the right. Because this graph has no rise, it means it's going to go horizontal. So this 3 is your y-intercept. So if this value here, being what it is, it tells you where you're going to hit the y-axis. So very simply, 1, 2, and 3 here. Now, because you're going to run 1 to the right, it would be the same level, the same y level as the first value. So if you do this a couple of times, notice that this thing is nothing more than a horizontal line. So in essence, the slope is 0. So the line is horizontal, or you call it flat. So there's no rise. So if there's essentially no x in the formula, just y equals a number, y equals a constant, you go to that number on the y-axis and draw a horizontal line. And then finally, if you take away the y and just put an x equals negative 4. Now, if you took away the x and you just have y is just straight up horizontal. But now if you flip the script and you took out a y instead of x, then horizontal becomes vertical. So this actually doesn't fit y equals mx plus b, so you have to kind of be intuitive about it. This is a vertical line because the x-axis is here and the x value is negative 4. I would find negative 4 on the x-axis somewhere here. I would put a dot there, this being a vertical line, which means essentially all you have is rising. So in this particular case, there is rise, but no run. So it will be the reciprocal of this one. So the m essentially would be something like 1 over 0. But that cannot happen in math, at least in algebra. So we say that the slope is undefined. So undefined means a vertical line, right? So x equals a number is vertical line, the slope is undefined. y equals a number, slope is 0, but it is horizontal. So slope is not something slants. So there's no slant. This is positive slant. This is negative slant. Sorry, let me say it again. This would be flat, where no rise, just straight up, straight left to right. Essentially, there is no slant. It's just straight flat. So for a positive slope, negative slope, no slope. Notice that number 4 is not a function. Just for your knowledge here, because there's a bunch of points that cheat here. So negative 4 just cheats with everybody. The other guys, just for your knowledge, they're all functions. Because as you can see, they all pass the vertical line test. As you can verify on your own. So 2.4 just kind of, can you graph a line essentially? Nothing too fancy, nothing too bad. So again, y equals mx plus b is the equation that we're looking for. That's all it is. So that would be an example of 2.4. So I'm going to do a few examples of 2.4, kind of the concept. So let me turn the page. And let me see if I can briefly talk to you about 2.5, which would be the equations of lines. Wait, sorry about that. Should be kind of straight here. If you take two lines now, or 2 points on a line, and like earlier in the chapter, call one point x1, y1, and one point x2, y2. Yes, you have a rise and you have a run, just like the previous one. However, the slope now, your m, as it was before, this is your rise, and that is your run. If you're talking about coordinates, this is second x, this is first x. So if you want to know that distance, it's x2 minus x1. That is the run. Here, y1, y2. Their difference would be the rise. Okay? So the rise over run really computes to be y2 minus y1 over x2 minus x1. So algebraically speaking, y2 minus y1 over x2 minus x1. This is another formula, or the formula for slope. And again, I'm pretty sure a lot of you are familiar. And then if you have a point on the line, let's say x1, y1, and a slope of the line, then y minus y1 equals m times x minus x1 would give you a different version of the formula of the graph, or we call this point slope formula. So if you're given a point x1, y1, and you're given a slope of the line, m, then you have this formula, what's called a point slope formula. So we have two formulas that we're going to use. We're going to look at the point slope formula, and we're going to look at the slope. First, I'm going to do a couple of examples of just finding the slope. Oh, I'm sorry, let me go back here. Remember that y equals mx plus b was the equation of the line, which we call slope-intercept. So now let's come back here and let's look at the slope. Let's say you have the points -3, 1, and let's say 5, -9. So like we did with the circles, and we did with the distance in the midpoint, we labeled x1, y1, x2, y2. So your little m here, now the other one was midpoint, capital M. Your m here is y2 minus y1, -9 minus 1 divided by x2 minus x1, 5 minus -3. So this would be -10 on top. The bottom would be what, 8? This simplifies because they have a 2 in common, -5/4. That would be the slope of the line between these 2 points. So let's say 4, -3, and 2, 5. x1, y1, x2, y2. Your slope would be the second y, 5, minus, I'm sorry to do like the bottom one here, the previous one. The first y is -3, divided by x2 minus x1, 2 minus 4. These two negatives become positive on top, so that's 5 plus 3 is 8. 2 minus 4 is -2. 8 divided by -2 would be -4. And that's your slope. Then I want to do some examples of finding the equation of a line. Example 3 here. So let's say that -5, 4 is on the line, and the slope of the line is 6. We want to find the equation of a line in slope-intercept form. In other words, we want to find the equation in this form, y equals mx plus b. We have a point on the line and a slope of the line, so we're going to use this formula. So -5, 4 is x1, y1. M is 6. The formula is y minus y1 equals m x minus x1. So y minus 4 equals 6 times x minus -5. Really, these two negatives we would make a plus. I should have put plus, but nonetheless, I wanted you to see where I got this. So x plus 5. Since we want to solve this equation for y by itself, my next task would be to distribute the 6. So y minus 4 is 6x plus 30 when you multiply. And now add 4 to both sides. Y equals 6x plus 34. And this is your equation. That's what it's asking. Let me do one more here. Let's say 4. Let's say 1, -2. Let's say slope equals to 2/3. And we can see that it's a 3 there. So x1 is 1, y1 is -2. Your m is 2/3. So your equation, now y minus, when you took a -2 here, I'll go ahead and put it. It becomes plus, but I'll put it for this problem. Equals m, y minus y1 equals m times x minus x1. So I'm going to simplify these two. Be plus. Now, normally what we do it like the previous problem. We distribute it 2/3. I know some people don't like to mess with fractions, neither do I. So I'm going to try something a little different. I'm going to multiply both sides by 3 to cancel this 3 down here. And I'm going to distribute what survives. So 3y plus 6 equals 2x minus 2. Then I'm going to subtract because I'm trying to get y by itself. So 3y equals 2x minus 8. And then I'm going to divide every piece by 3. In other words, kind of like both sides by 3. So we get y equals 2/3 x minus 8 over 3. And then the ever so boring slope equals 2. Let's say 1/4. Y-intercept is equal to 5. For this one, it gives you the slope and the y-intercept. So we want to get it in the form the slope and y-intercept. So in the very odd, very rare case when they give you the slope and the y-intercept, you already have the information because m is your slope and b is your y-intercept. I should have put that up here. B. So you have the values, your formula, because you already know what the y-intercept is. This strictly just becomes y equals 1/4 x plus 5. It won't, pretty much it won't ever be that easy, but I thought I'd throw in one example of this. Okay, so I'm almost done here. Let me do just one more here. Let me do two more here. Let's say you have a line passing through -1, 5 and 3, -7. For this particular problem, we have to find the slope first because we don't know what it is. Always in a line, when you're trying to find the equation, slope is very important to have. So m equals second y minus the first y. We have to actually compute it. Divided by second x minus the first x. -7 minus 5 is -12. 3 plus 1 is 4. So -12 divided by 4 is 3. So now I'm going to use the formula, the point slope formula. The formula that has this value, this equation. And so I have my x1, y1, I have my m. So my equation then becomes y. Now because minus y1 and y1 is 5, it's y minus 5 equals to -3. Now parentheses x minus x1. When you subtract a -1, it becomes positive. When you subtract a negative, now I have my equation set up. I'm going to solve for y by first distributing the x. So I have -3x minus 3. And I'm going to add 5 to both sides. Y equals -3x plus 2. And that is your equation. One more here. Let's see if I can take. I'm going to have to show you about parallel and perpendicular here. So let's say a line passing through. So maybe a couple more examples. Passing through 2, 3, and 5, 1. x1, y1, x2, y2. Your slope, second x minus your first x. I'm sorry, second y minus your first y, 1 minus 3, divided by the second x minus the first x. 5 minus 2, excuse me there. So this is negative 2 on top. This is a positive 3 on the bottom. So negative 2/3 is your slope. So then your formula is y minus y1. y1 is 3. So y minus 3 equals m, which is negative 2/3, parentheses x minus x1, which is 2. What I'm going to do what I did in the previous example and have a fraction. I'm going to multiply both sides by the denominator of that fraction to cancel the denominator out. And what's left, I'm going to distribute. Hopefully try to isolate the y. So 3y minus 9 equals negative 2x plus 4. Negative 2 times x, negative 2 times negative 2. So now I add 9 to both sides. 3y equals negative 2x plus 13. Divide both sides by 3. Each piece by 3. Y equals negative 2/3 x. Oh, sorry. Y equals negative 2/3 x plus 13 over 3. And that's how you essentially find the graphs of the line. And so, for your information, one, two distinct lines are parallel. Means they run next to each other. They run together. They never touch. If they have equal slopes. So y equals 2x plus 3. Y equals 2x minus 4. Or let's do it like this. Slope of the first line is 2. Slope of the second line is 2. Slopes are equal. So the two lines are parallel. Okay. Let me do one more here. Let's say y equals 3/5 x minus 1. Y equals 3/5 x minus 6. Both slopes are equal. They're both 3/5. So both lines are parallel. Parallel means the same slope. They never touch. Two lines that run next to each other, parallel. And the last idea, two distinct lines are perpendicular if their slopes are negative reciprocals of each other. Which means, as it were, the slope of one is the reciprocal of the other and the opposite sign of the other. So y equals negative 3/5 x minus 4. Y equals positive 5/3 x plus 1. So let's say slope 1 is negative 3/5 because again y equals mx plus b. Slope number 2 is positive 5/3. So notice that both of them are reciprocals of each other and opposite signs. So perpendicular, I'm going to explain that. It's when two lines intersect at a right angle. So we say both lines are perpendicular. The universal symbol for perpendicular is an upside down capital T. That's what it means, perpendicular. And if I may here, one last one here. Say y equals 3x plus 4. Y equals negative 1/3 x plus 8. Slope 1 is 3/1. Slope 2 is negative 1/3. Again, reciprocals and opposite signs. So both lines are perpendicular. Perpendicular. Excuse my penmanship. I guess perpendicular to each other. Both lines are parallel to each other. To each other. They're parallel with respect to each other. And this concludes 2.4 and 2.5.